Hello all, welcome back to my channel. Today we'll be discussing regarding the chapter laws of motion. So in this video we'll only be discussing about the three laws of the Newton, applications of Newton's laws in daily life, and we'll be having a quick summary of those laws of motion. Then we will be discussing about three more important topics, which is momentum, impulse, and conservation of momentum, the law of conservation of momentum. So Newton's laws of motion form the foundation of classical mechanics and are crucial for understanding how objects move. These laws apply to all objects whether they are at rest or in motion. So this is the overview that we are going to see in the video. So the topics that are going to covered are Newton's laws of motion, conservation of linear momentum, friction, and universal circular motion that would be covered in the next video. So here's the Newton's first law of motion. It states that an object at rest will continue to remain at rest, and an object in motion will continue in motion with the same speed and the same direction unless acted upon by an external force. This is also known as the first law of inertia. Inertia is the tendency of an object to resist changes in its state of motion. Example: a book lying on a table will remain at rest unless someone pushes it. A car moving at a constant speed will continue to do so unless brakes are applied or another force acts. This law explains why passengers feel pushed forward when a car suddenly stops. They are continuing in their state of motion. So, Newton's second law states that the force acting on an object is equal to the mass of that object multiplied by its acceleration. F equals ma. This law quantifies the relationship between force, mass, and acceleration. Force: the push or pull acting on an object. Mass: the amount of matter in an object. Acceleration: the rate at which an object's velocity changes. A car with more mass requires more force to accelerate at the same time as a lighter car. Practical application for this law is that this law is used in engineering to design vehicles, calculate the amount of force required for momentum, and in calculating projectile motions. So this is the third law. Third law states that action and reaction. Okay, third law is simply about action and reaction. In this, yes, third law is all about action and reaction. So the practical application for Newton's third law is that the propulsion of air from a jet engine or the recoil of a gun when it is fired. So to summarize all the laws of motion, we have that first law is related to inertia. Objects remain at rest or in uniform motion unless acted upon by an external force. Second law, F equals ma. The force acting on an object is equal to its mass multiplied by its acceleration. Third law states that action and reaction. For every action, there is an equal and opposite reaction. These laws form the foundation for understanding motion, forces, and behavior of objects in both everyday life and complex physical systems. Now let's see what is momentum. Momentum is a vector quantity, as it is the tendency of a body to remain in motion. Linear momentum and angular momentum are the two types of momentum. Momentum depends on mass and velocity. The total momentum is conserved. Impulse in physics is a term that is used to describe or quantify the effect of force acting over time to change the momentum of an object. It is represented by the symbol G and is usually expressed in Newton's second or kg meter per second. Impulse is often stated to be the product of the average net force that acts on an object for a certain duration. The equation for impulse is given as J equals F naught F into delta T. Note: we assume that force is constant over time. Impulse is a vector quantity like force, and it also has direction. Law of conservation of linear momentum. Conservation of momentum is a major law of physics which states that the momentum of a system is constant if no external forces are acting on the system. It is embodied in Newton's first law or the law of inertia. The law of conservation of momentum is generously confirmed by experiment and can be mathematically deduced on the reasonable perception that space is uniform. Conservation of linear momentum is based on Newton's second law of motion, which states that in an isolated system, the total momentum remains the same. Having said so, the energy of a system is always conserved. One of the best applications of the law of momentum would be in space travel. There is no medium in space to exert a force on. Then, how do rockets travel? Well, they eject matter at a very high speed. So, in an isolated system, the momentum should remain constant. Therefore, the rocket will move in the opposite direction with the same momentum as that of the exhaust. So, these are some real world applications. Everyday examples that we have are one real world application for Newton's laws is satellites in orbit. Sports we can consider as momentum and impulse, and transport we have friction and circular motion. That is all for today. This is the part 1 of the laws of motion. In the second part we will be discussing about the collisions, frictions, etc., and even uniform circular motion. So that's all for this video. Thank you and have a nice day.